NASA confirmed Thursday that the Voyager 1 probe has made history by becoming the first human-made object.
NASA says its Voyager 1 probe, the most distant human-made object in the universe, is sending usable information to Earth again.
What if the universe wasn't silent at all, but whispering, quietly sending signals across the stars? Not in light, not in radio waves, but in something deeper, embedded in the very structure of space itself. That's exactly what NASA's Voyager 1 might have just uncovered. After nearly 50 years and over 15 billion miles from Earth, this aging spacecraft has picked up something completely unexpected. A persistent, organized plasma wave. Something no one believed could exist out in the cold interstellar void. This isn't science fiction. It's happening right now. A faint, rhythmic hum is rippling through the space between stars. And it's not noise, it's structure. Voyager 1, long thought to be at the end of its journey, may have just stumbled onto the biggest discovery in astrophysics in decades. What does this mean? And what does it say about the nature of space, time, and possibly even intelligence itself? Let's dive into the impossible. Voyager's return to relevance. The signal that shocked scientists. For years, Voyager 1 has quietly drifted through interstellar space, the most distant human-made object ever created. Its mission was once thought to be over, its instruments fading with time. But then, in late 2020, something incredible happened. Despite its aging hardware, built in the 1970s, Voyager began transmitting usable data again. And not just any data. This wasn't static or background noise. It was a clear, repeating signal, a plasma wave oscillating in a way scientists had never seen. Initially, experts suspected the readings were a fluke. After all, how could a 50-year-old probe still function in such extreme conditions? But as the data kept coming in, consistent and structured, it became clear. This wasn't a malfunction. It was real, and it defied decades of assumptions. The plasma wave wasn't chaotic or random, as one would expect from the thin interstellar medium. It was organized, coherent, as if Voyager had tuned into a song written in the language of space itself. The implications were immediate and staggering. If such waves exist out there, then interstellar space is far from empty. It's active, dynamic, and possibly even communicative. This realization is reshaping how astrophysicists think about the galaxy. For so long, we assumed the regions beyond our solar system were cold and inert, little more than a scattered mix of particles. Now Voyager suggests we may have been wrong. Space isn't silent, it's singing. And we're just beginning to hear the first notes. A mysterious order, plasma waves that shouldn't exist. The interstellar medium, the vast space between stars, has always been thought of as more or less a void. It's cold, sparse, and chaotic. Sure, it's filled with hydrogen atoms, a sprinkle of cosmic rays, and faint magnetic fields, but nothing that could form large-scale structure. At least, that's what we believed. Until now. Voyager 1's plasma wave readings showed something that shouldn't be there, a stable, oscillating pattern. Imagine listening to static on a radio and suddenly hearing a clear, rhythmic melody emerge. That's what Voyager's instruments picked up. These weren't random cosmic fluctuations. They were repeating waveforms, humming across hundreds of millions of kilometers in space. At first, mission control suspected instrument failure. Understandable, given Voyager's age and the constant cosmic radiation it's endured. But multiple checks confirmed it. This wasn't a glitch. The signal was consistent, coherent, and entirely unexpected. What makes it so groundbreaking is that the frequencies didn't match any known source. No solar shock waves, no magnetic turbulence. This wasn't caused by the sun or any nearby planets. Instead, the patterns resembled something more exotic, standing waves. These are stable waveforms you'd expect in solid structures or crystal lattices, not in the scattered and dust of deep space. This changes everything. Suddenly, interstellar space doesn't look empty. It looks like a structured, resonant medium, a place where energy moves in complex, predictable ways, a place that might even transmit information. The idea that the void between stars is actually organized and patterned is enough to turn decades of astrophysics on its head. And Voyager 1 is the first to show us the evidence. A galactic song or an alien signal? The origins debate begins. As the data rolled in, one question began to rise above all others. What exactly is causing these plasma waves? The scientific community quickly split into two camps. On one side, researchers suggested natural causes, perhaps ancient supernova remnants or magnetic reconnection events had created lingering ripple effects in the interstellar medium. On the other, a smaller but growing group of scientists entertained something more radical, the possibility that these waves might be artificial. It sounds wild, but their reasoning is not without merit. These oscillations were strangely harmonic. Not only did they repeat consistently, but the structure within them resembled something engineered. There were intervals and amplitudes that followed mathematical relationships, almost like a message. Could an intelligent civilization have imprinted patterns into the plasma itself, not using radio waves or lasers, but space as the medium? It may sound like science fiction, but some SETI researchers argue that if an advanced species existed, it might communicate in forms we haven't even begun to consider, using space's natural fabric to carry information across light years. Voyager 1 may have, by complete accident, drifted into such a structure, a cosmic whisper meant to be heard by any civilization capable of listening. However, the majority of scientists still lean toward natural explanations. The interstellar medium is shaped by ancient cosmic forces, exploding stars, colliding particles, vast magnetic fields. But even natural processes can produce patterns so intricate they border on artificial. Either way, what Voyager has found is far from ordinary. Whether this is the echo of a galactic catastrophe, a remnant of ancient star birth, or an interstellar postcard from another mind entirely, one thing is clear: something is out there and it's organized. And we've only just begun to understand it. Interstellar weather and the future of space travel. Voyager 1's discovery is also making engineers rethink how we move through space. If plasma waves can exist in structured, predictable forms across the galaxy, then interstellar space isn't just emptiness. It's a navigable terrain. Much like ancient sailors used ocean currents and stars to guide their ships, future spacecraft might be able to ride or navigate by these invisible plasma corridors. This idea has sparked bold new concepts in space propulsion. What if probes could surf these waves using their energy to accelerate without needing vast fuel reserves? The interstellar medium, once considered hostile and dead, could become a power source, a map, and even a pathway. There's also the tantalizing prospect of energy harvesting. Some early theoretical models suggest that plasma waves, under the right conditions, could be tapped for low-level electrical current. If these structures are consistent across vast regions, spacecraft might one day extract energy on the go, extending missions for decades, maybe even centuries. But this goes beyond propulsion. Scientists are now speaking of interstellar cartography, a new kind of galactic mapping based not on stars and planets, but on plasma wave patterns. Think of it like a cosmic GPS, where the signal, strength, and frequency of these waves help pinpoint your location in the galaxy. Voyager 1 may have just given us our first point on that map, and then there's cosmic weather. If these waves influence the movement of particles across space, they could explain strange fluctuations in cosmic ray patterns we detect here on Earth. They might even protect or expose spacecraft to sudden bursts of high-energy radiation. Understanding this interstellar weather could be crucial for future human missions beyond our solar system. Space isn't empty, it remembers. Perhaps the most haunting implication of Voyager 1's data is the idea that space has memory. Those coherent waves, those repeating structures, might be ancient echoes, long dispersed starbursts, fading signatures of galactic formation, a kind of fossil record, not made of stone or bone, but of energy. Just as tree rings tell us about ancient climates and ocean sediments preserve the story of Earth's past, these plasma structures might hold the history of the galaxy. If that's true, then Voyager didn't just detect a new physical phenomenon. It may have stumbled into a kind of cosmic archive. Some theorists believe that these waves could be remnants of the Milky Way's birth, frozen in space like ripples in a pond. Others think they're evidence of recurring galactic rhythms, slow, deep pulses that shape how stars form and die over billions of years. If Voyager 1's signal is one of those pulses, it may have tapped into a kind of interstellar heartbeat, a rhythm that keeps time across the galaxy. But this idea isn't just poetic. It has practical weight. If we can map these signals across space and understand their timelines, we might begin to decode the history of stellar events, ancient supernovae, the collapse of massive stars, even the movement of black holes. In other words, space becomes a storybook, and Voyager has just read us the first page. This challenges how we see the universe. It's not just a stage where cosmic events happen. It's an active participant, a keeper of memory, a place where the past still hums quietly in the dark, waiting for something or someone to listen. The science of the unexpected, a real-world laboratory in the stars. For decades, plasma physics and interstellar studies were largely theoretical, models built in computers or inferred from indirect signals. But Voyager 1 has flipped the script. It's now delivering real data from a region of space we've never been able to physically study before. It's like stumbling upon a laboratory already running an experiment, 15 billion miles away. The plasma wave subsystem aboard Voyager 1 was originally designed to study the magnetic fields of planets like Jupiter and Saturn. No one imagined it would be capable of picking up structured signals in deep space. Yet here it is, performing far beyond its intended lifespan and function, delivering the first known evidence that the interstellar medium is more than random dust and gas. This real-world data is now feeding a frenzy of theoretical work. Physicists, signal analysts, and even linguists are jumping in to interpret the structure. Some researchers compare the waveform's harmonic patterns to the low-entropy signals, patterns that usually occur in systems carrying information, such as DNA or human language. It's not that they're saying it's a message, but it sure behaves like one. This has implications beyond astronomy. Fields like quantum mechanics, magnetohydrodynamics, and unified field theory are suddenly looking at Voyager's findings as potential evidence to test long-held mathematical ideas. Could these plasma waves tie gravity, magnetism, and the quantum world together? It's speculative, but deeply exciting. Even more fascinating, Voyager may have just scratched the surface. Scientists now believe the spacecraft might drift into more such wave structures, or areas where these oscillations intensify, forming what they call resonance zone. Each zone could behave differently, offering a spectrum of real-time galactic data, almost like stations on a cosmic frequency dial. Life between the stars, rewriting the rules of biology. For the longest time, the space between stars was considered utterly inhospitable, a graveyard of radiation, freezing temperatures, and empty darkness. But Voyager 1's plasma discovery has reopened a question long buried. Could life exist or travel out there after all? The implications are not about little green men and flying saucers. Instead, some astrobiologists are entertaining the idea that microbial life, especially tough, dormant forms like spores or extremophile bacteria, might be able to hitch rides across space, not by accident, but by nature's design. If these plasma waves influence the flow of particles and energy through interstellar space, they might form protective corridors, regions where radiation is dampened or where temperature gradients create tiny oases of stability. These wouldn't be habitable in the conventional sense, but they could preserve or transport biological material across unimaginable distances. This gives new life to the panspermia hypothesis, the idea that life can spread from planet to planet, or even star system to star system, via comets, asteroids, or dust. Voyager 1's discovery doesn't prove panspermia, but it dramatically increases its plausibility. Suddenly, space doesn't look like a vacuum. It looks like a highway with cosmic rest stops, and the biological connections don't end there. Some scientists are analyzing the waveform's layered harmonics to see if they mimic any known biological rhythms. Could the galaxy itself have patterns that resonate with life? Could organisms adapt to these cosmic pulses in some way we don't yet understand? These are massive questions, and we're nowhere close to having answers. But the mere fact that we're asking them again, because of a 50-year-old spacecraft still flying in silence, shows how profound this discovery really is. Rethinking alien communication beyond radio waves. One of the most provocative outcomes of Voyager 1's discovery is how it's forcing us to rethink how intelligent life might communicate. For decades, the search for extraterrestrial intelligence, SETI, has focused on electromagnetic signals, radio waves, light pulses, laser beacons. But what if that's all wrong? Voyager's plasma wave discovery introduces a startling possibility. What if intelligent civilizations have been using the interstellar medium itself to communicate, embedding messages into the very plasma that fills space? Unlike radio signals that fade with distance, plasma waveforms can sustain themselves over vast ranges without degrading in the same way. It's like carving a message into the ocean current instead of shouting across it. This would explain why we haven't found the wow signal we've been expecting. We might simply be listening in the wrong way, expecting sound when we should be reading vibrations. If an advanced civilization wanted to be subtle, almost poetic, it might choose to modulate waves in space itself. And Voyager 1, by sheer accident, may have tuned into one of these galactic whispers. Even if the waves are natural, their layered structure is strangely suggestive. They're not just repeating, they're stacked, cycling at different intervals in what looks a lot like multi-channel encoding. The structure isn't chaotic, it's ordered. And if it's ordered, there's a chance it carries meaning. That chance has reignited interest in SETI. Researchers are now considering building new detectors, not just radio dishes, but plasma wave analyzers that can scan for signals embedded in space itself. It's a whole new frontier in the search for intelligence. A galactic map, hidden in the noise. When Voyager 1 first launched in 1977, no one imagined it would one day help us chart an invisible architecture of the galaxy. But here we are, nearly 5 decades later, watching scientists rethink the entire concept of space mapping based on its discovery. The structured plasma oscillations Voyager encountered may be more than just a strange anomaly. They could be signposts on a vast cosmic grid. Researchers now propose the idea of a spectral geography, a map of the galaxy defined not by stars or gravitational pull, but by resonance. In this model, the Milky Way isn't just a collection of star systems, but a dynamic network of energy zones where plasma behaves in organized, repeatable ways. These resonance zones may line up with ancient stellar remnants, black holes, or even the paths of migrating galactic material. The waves Voyager 1 detected may be phase coherent, meaning they stay in sync over vast spans of time and space. That level of coherence suggests something is holding them in place. A deep magnetic scaffolding, perhaps, a kind of galactic backbone, vibrating quietly in the background of everything. Understanding the structure could help us map interstellar weather patterns or forecast cosmic ray concentrations. It could even guide future interstellar missions, like lighthouses in the dark. Think of it like sailing across a turbulent sea, but being able to follow the calm currents. Spacecraft could use these zones for both navigation and energy efficiency. The sheer age of these structures also introduces a stunning new possibility. What if they are galactic fossils? Remnants of early formation events. If these plasma waveforms were imprinted when the Milky Way was young, they may hold a record of cosmic evolution. Echoes from the birth of stars, spiral arms, and black holes. The patterns Voyager has uncovered may not just describe where we are in the galaxy, but how we got here, from ancient tech to future potential. Perhaps the most poetic truth in this entire story is that Voyager 1 was never built for this. It was meant to explore the outer planets, Jupiter, Saturn, and then fade into silence. Instead, it's become our furthest reaching emissary, still transmitting data while powered by less electricity than a refrigerator light bulb. And now it's making the most profound discovery in its entire mission. The instrument responsible, the plasma wave subsystem, was never intended to map deep space, yet it has become our first ear tuned to the hum of the cosmos. This alone is a triumph of engineering and foresight. But more than that, it's a reminder of the value of long-term exploration, of patience, persistence, and optimism in science. Voyager's accidental discovery is already reshaping funding, pushing agencies and universities to invest in plasma-based detectors and new propulsion concepts. If we can someday harness the energy of these waves or use their structure for interstellar navigation, It could change how we explore the stars forever. Even now, labs across the world are trying to recreate interstellar plasma conditions in miniature, simulating the exact oscillation patterns Voyager recorded. These simulations could lead to breakthroughs in fusion energy, quantum communication, and even the elusive theory of everything. We might not just be looking at deep space, we might be looking at the very underlying structure of reality itself. It's no exaggeration to say that Voyager 1 may have found a piece of the operating system of the universe, hidden in plain sight, humming quietly in the dark, waiting to be heard. And there it is. A spacecraft launched when disco was king and rotary phones ruled the Earth may have just uncovered the first whisper from the universe's hidden structure. Whether this discovery points to new physics, ancient galactic history, or even signs of intelligence, one thing is certain. Voyager 1 has changed how we listen to the cosmos. Emergent intelligence. Could the universe be thinking? As the debate around Voyager 1's plasma wave discovery intensifies, a bold and speculative idea is gaining traction in philosophical and scientific circles alike. What if the universe itself exhibits signs of emergent intelligence? This concept doesn't imply a conscious being directing the cosmos like a puppet master. Rather, it suggests that complexity can arise from simple rules, a phenomenon well documented in systems from ant colonies to neural networks. Voyager's detection of large-scale, organized, oscillating plasma structures hints at something similar happening across the galaxy, a form of self-organization that in some ways mimics thought. Here's the mind-bending part. These plasma waves show not just repetition, but adaptability. They seem to interact with their environment, sustain patterns over time, and resonate in harmonics similar to those found in biological systems. Could these structures be the galactic equivalent of synapses, nodes of energy where information naturally flows, amplifies, and even evolves? Some researchers are drawing parallels between interstellar wave structures and brainwave activity, not to suggest the galaxy is literally a brain, but to consider the possibility that it might process information in a way we don't yet understand. Could the cosmos be a kind of distributed intelligence, where matter, energy, and resonance create feedback loops on scales too massive for us to recognize? If true, this changes everything. It redefines not just our search for alien life, but our understanding of consciousness itself. Perhaps intelligence is not confined to carbon-based organisms on wet planets, but exists in a more abstract, field-like form, embedded in the very physics of the universe. Voyager 1's discovery may be the first glimpse into this deeper layer of reality, one where space isn't just a medium, but a message, and the universe isn't just observed, but participates in its own unfolding. If you found this journey through deep space as mind-blowing as we did, make sure to like, subscribe, and hit the notification bell for more deep dives into the mysteries of the universe. And let us know in the comments, do you think this was a natural phenomenon or a message waiting to be heard? Thanks for watching. See you in the next one.